All right, these final problems will make use of some of the theorems that we learned towards the end of things here. Let's look at number 7. We're asked to find the unknown arc, which is arc TS going this direction. And we don't know anything except for this angle UTS. So what we can do here is we can use this angle to determine the intercepted arc. And we know if the vertex of the angle is on the circle, as it is here, then the measure of the intercepted arc, which would be this arc right here, is going to be twice the measure of the angle. So if I take 81 times 2, that gives me a measure of 162 degrees for this arc. And you'll notice this arc and this arc together are going to make up the entire circle. So if I take 162 plus my unknown arc, they have to add up to the total arc measure of the circle, which is 360. So all I have to do is take 360 and subtract 162. And what I'll find is that the unknown arc measure would be 198 degrees. Now I'm glad this comes up. This allows me to point out a naming convention that we have, because this arc would be named arc TS, and this arc would be named arc TS as well, and we need a way to tell the difference. And the way we tell the difference is by calling them major and minor arcs. So when a circle is divided into two arcs, the bigger of the two, so in this case 198, is what we call the major arc. So this is the major arc TS. This one, the smaller one, is called the minor arc of TS. But in either way, the major arc TS is going to be 198 degrees in measure. All right, for number 8, here we're looking at a situation where we have chords and they meet and they form an angle on the interior of the circle. And so when our angle or the vertex of the angle, is on the interior, we know that 2 times the angle is going to be equal to the sum of the arcs. And we can now use that to our advantage. We know what the angle is, so we can say 2 times 180 is going to be equal to this arc, which is 55, plus this arc, which is, I don't know. So 2 times, not 180, but rather 108 would be 216. So 216 equals 55 plus our unknown value. Subtract 55 from both sides, and we find that our unknown value would be 161 degrees. So the measure of this arc would be 161. And again, that's because if you take this arc plus this arc, it has to be twice the value of that angle, or the measure of that angle. All right, number 9 shows us our final situation that we haven't looked at yet. What if we have an angle whose vertex is on the exterior of the circle? And when this happens, we can say that 2 times the angle is going to be equal to the difference in the arc measures. So the difference of the arcs. So when we set that up, we know our angle measure. So we take 2 times 49 is going to equal, now difference means subtraction, so we want to take the bigger one, that would be the one on the outside, minus the inside one, which is our unknown value that we're looking for. So I can go ahead and figure up 2 times 49 would be 98. So 98 equals 143 minus our unknown value. If we're going to be technically correct in solving this with algebra, we'll add our unknown value. It feels really weird leaving that as a question mark instead of x. But then we get 98 plus our unknown value is 143. Subtract 98 from both sides, and you'll find that your unknown value then becomes known. It's going to be 45 degrees. So again, using the fact that when the vertex is on the outside, twice the measure of the angle will be the difference of the arcs.